This morning I want to continue with the Game Boy ROM Header Extractor tool that I started working on. It works actually quite well, so we're able to create a CSV file with all the ROMs. With all the header data of the ROMs in nice table formatting and everything. So that part works, although it's all a bit janky at the moment. So the focus for today will mainly be some more cleanup and also adding command line arguments, because I want this tool to be a bit more flexible. At the moment you just double click, you basically start the executable. It looks in the folder that you started the executable from, and recursively travels through all the subfolders and reads all the files within those folders, no exception, and tries to extract Game Boy header data out of those files. Whether they're Game Boy ROMs or not, doesn't matter. Just trying to fetch that data out of there. And yes, so I just want to allow a few more things to be done. So let's go to the to-do list. Hang on. There we are. So I want to allow an input directory to be specified, so you can actually select a different directory from where the executable lives, so you can put the executable wherever you want to, right? You can just specify an input path. If you don't specify one, it should just pick the current directory the executable is in, well, the current working directory, that is. I want to allow an output directory to be specified, because at the moment it just puts the CSV file directly where the executable is, right? Which is not great. So, whoops, where are we? Projects, we use projects. So here you can imagine if I have the GB Extractor. Didn't even start Visual Studio this morning. Blimey. Okay, so the GB Header Extractor, if I were to run this now, right, it runs within this folder and it just creates the output CSV file right here. I can open this up just to show you as a recap what it looks like. You see it has all the file names in here, in the file name header, then we have the title. Obviously these are not ROMs, so it will just spew out garbage data basically. My keyboard is not even connected to this machine. Oh my lord. So unprepared this morning. Okay, now the keyboard should be connected. Yep, there we go. Let's just delete these. Delete rows. And let's just keep the ROMs in there. So the reason why it just reads every file is, again, I didn't want to limit this tool based on the file extension, because like you could choose different file extension names for your Game Boy ROMs, right? It could be just .bin, I don't know what. You could basically choose anything. The file extension doesn't really matter. It's sort of just an indication for programs. I think a rather stupid one, to be honest, but hey, whatever. Anyways, as you can see, we read out the title. We read out the game code. These are old cartridges, so they don't have a game code associated with them. We read the maker, which is Nintendo. Obviously no Game Boy Color support, because these are original Game Boy games. So this one was just a test. Let's delete one. I only have those two cartridges, really. We have Super Game Boy support, which these two ROMs also don't have. We have the pack type, the ROM type, the RAM size, the destination, and the version, right? And the nice thing with this is, because it's just a comma separated value, you can open it with any tool, either LibreOffice or Excel if you have that, and you can just, save that in their specific format, sort the data based on title or ROM size, if you want to figure out, hey, which ROMs have like 32 kibs and stuff like that. On a note on this one, I tried this out yesterday to sort it in ascending order via ROM size, and I noticed the kib and mib that I have stored in there kind of screws things up. So I think what I'll do is just put the number values in there and specify in the header that all these values are listed in kilobytes. That should make sorting a bit easier. So yeah, okay. So this is the tool as it works now, basically. Oh no, didn't want to do that. Don't save. Okay, cool. Also, we probably should get rid of these error messages here and stuff. Okay. Where do we begin? Oh, another thing, I also don't think this dynamic buffer that I created is necessarily a good idea, because we should be writing in the same chunk size as we're reading from files. So ideally what I would like to have is just a 4 kilobyte buffer, write into that 4 kilobyte buffer until it is full, and as soon as it is full, write it out to the file, and then, you know, basically fill the buffer up from 0 again. The C runtime actually does that by default if I choose to write into the file. And given that I will also want to allow piping with this tool, so you can just pipe the output of that tool into whatever other command line tool you have, right? I should probably just use the C runtime file writing stuff instead of like this whole thing that I did here with the dynamic buffer. It was a fun little exercise, but probably a bit overkill for this tool. Let's put it this way. This would be useful if I don't really want to use the C runtime anymore and just, you know, call the Windows APIs instead. But then I also wouldn't call fopen, right? I would call whatever Windows is using. I think for Windows it's create file. But yeah. But let's do one thing after the other. Probably should also put some stuff in the header files, to be honest, just to clean up the main.c file a little bit. So let's do command line arguments. I think if you do not provide command line arguments, argc, which is argument count, right, will still be 1, because I think the name of the executable will always be the first argument. Similar this one. This is an array of char pointers, so basically strings. Similar, this one will always have one value, which is the name of the executable. Let's try and prove that, right? Let's do printf. Also just realized we're specifying this to be a Unicode application somewhere. Where did we do this? Oh, there we go. Character set, Unicode character set. So I think the arguments that are being passed in should actually be wchar_t as well. But that I need to verify. Hang on, let's do that first. Let's try and verify that first. So Windows crt main wchar_t. So every program has a main function. Yeah, we do know that. That is fine. This is main. It can either have arguments or not, and it can have this. Oh, what is this? I've never seen that one. Traditionally, if a third parameter is passed to main, that parameter is named env_p. What is env_p? Eh? never seen that. Interesting. Okay. In the Unicode programming model, you can define a wide character version of main using wmain instead. There we go. This is what I wanted. Cool. So it's just wmain instead of main. We have argc and argv, and this is with wchart. Excellent. The envp environment. Hang on, was that in main as well? No, they didn't have that in there. Okay, what is envp? Environment. Is this like environment variables and stuff? Interesting. Okay, here we have some information. Microsoft specific. Ah, there we go. Okay, it's Microsoft specific. The envp parameter is a pointer to an array of null terminated strings that represent the values set in the user's environment variables. Cool. I didn't know that. I mean, I won't be using that because I find environment variables quite confusing, to be fair. So not sure I'll be using those. Okay, parsing C command line arguments. Okay. The first argument, 0 is treated specially. Yep. And I also won't worry about environment variables. Okay, but what we should do is use wmain and wchart, because we are in Unicode world anyway. So, and then we can do printf. Let's print the number of arguments, right? And let's check out what that first argument is. 0 rep. Let's put 2 new lines in there. There we go. We have 1 and what? Oh, is it? I have to use white printf, don't I? Nope. What are you complaining about? Oh, again, every time. These white strings get me every single time. There we go. So we have the first command line, so we have just one command line argument, and as you can see, it's the name of the executable. Sweet. Which reminds me, if we were to run this tool, let me show that to you actually. Let's go to the debug and copy our executable into this folder right here, right? So if I were to run this tool from in here right now and open the output CSV, what you'll see is that the executable itself is being treated as a GameBoy ROM, right? Not great, but what we can do, since the first argument is the name of the executable, why do I always click save? Since it is the name of the executable, we can just ignore it while going through all the files. So let's go to the in here through the loop where we like iterate over the files. and then we just check the file name in here. So what we can say is, actually, we can do that. Yeah, let's do that in here. So if string compare, and I know you're able to access environment variables through anywhere in the program, right? Because this is like a global that's just being passed in. But I don't know what the function name for this is. Global variables. There we go. We have argc and argv. Sweet. Is there like a recommendation that we should use a method for it, or can we just access them as is? We can just access them as is. Fantastic. So what we can do is string compare. We have our input buffer in this function right here, which is the file name we are about to read the header out of, and we can just compare if it is the same as hang on, it's not string compare, is it? It is wide character string compare. I hate these names. Okay, we have our input buffer and we can compare it with the first argument. And if they are not the same, we continue with reading the header. Otherwise, we'll just ignore it, right? Okay. Exception thrown. I thought I had exceptions disabled. I think it's just debug thing. Okay, so right, what's happening? argv is not why is it not set? What is happening here? Ah, it's wrgv. Okay. Oh, interesting. So what we can see is it's not directly, it's sorry, it's not directly declared as variables. They have these macros where they call these functions right here, and I wonder why that is. Okay, what does the internet say about this? Come on, Google, you're giving me this page and this is not even in here. What the hell? Sorry, DuckDuckGo, I guess. Declare, no, not even, no, what? Can't find anything about this. Are you serious? Okay. Cool, I guess. Does it change if I switch into release mode? No. It's just doing functions. Environment can only go via functions. Whatever. Let's not get too hung up on this. So we need wrgv. That is what we need anyways. And then let's just not bother with the rest. Okay, so we have this. That works fine. So let's see if we still get the same output. Let's go here, debug, copy the executable down into here, replace, delete the output, run, open the output and see if our executable is in there. And it is not. We successfully ignored the executable. Cool. That's one thing done. Again, I'm always clicking save. Jeez. Okay. Okay, so now that we ignored the executable, let's go to business with the command line arguments. So it's probably best to have a table of what I actually want to achieve, right? So we either have an input specified or not. We have an output specified. We have an input directory specified or not. What if this is a file? Right, we have to check that. We have an output directory specified, or we can have an output file specified. File name. Then, regardless of which mode, so basically, I also want to allow piping. So let's see, how do we do this? I think what we should do then is have a command line flag that allows piping. So piping enabled. If piping is enabled and an output directory is specified, we should still be able to write to the file, right? Because maybe you want both. Maybe you want to write to a file and also pipe it into a different program. But what if you specifically do not want a file, but you just want piping? Maybe we should specify something like no file. So this could be minus minus pipe or minus p. This could be minus minus no file minus n. Recursive or not. Minus r. Yeah, probably best if you specifically need to enable recursive mode. Otherwise, it's a bit shitty if you just double click on the executable and it suddenly crawls through your whole hard drive because you put it in C or something, you know. That would be bad. So, am I missing something? Header. Table header on, table header off. We can say this is headless. I don't know if I want these short arguments, to be honest. I'm usually one for very descriptive names, so I'd probably just do these. If we wanted to have Windows style things, we would actually have to do it like that. I think that's what Visual Studio is doing, right? If we look here, command line, all options. No, I think command line. What? Oh, there we go. Yeah, so they're all specified via slash. And since this is a Windows only tool, I probably should adhere to that. I mean, if that is what Windows people are used to, I'm not sure. I do like the minus minus stuff though. Or just minus, to be honest. I'll just have it with minus. Whatever. let's just decide this is it. This is my truth. There we go. Deal with it. If you don't like it, rewrite the program. Okay, this would be output. Right. Same for that one there. Let's do it like this, and this would be input. So if you have no file specified and there's output, we should add out a warning that output will be ignored. No file would automatically mean piping, so this is kind of redundant. So if we have no file specified, it would automatically write to std out. So no file and pipe are kind of redundant, okay. But you can have pipe specified. Let's name this std out. Yeah, okay. Might be a bit confusing, but whatever. Let's just leave it as is. Is that it? Am I forgetting something? Appending to a file instead. So if append is enabled, the table header should be automatically off, right? Unless the file doesn't exist, then it should add the header. Unless you specifically specify append and headless. Oh dear. Okay. Well, flexibility comes with a cost of maybe being slightly confusing. Who knows? I think this is okay. Maybe I shouldn't try to be clever with append and remove the table header. We'll see. We'll see if I get. Okay, what else? UI mode. Yeah, we're not doing that yet. But eventually, Win32 UI mode, right? With GUI. This is special and would ignore all the other ones and just launch it into UI mode. How you would do that is just create a symbolic link to the executable that you have and specify this command line argument, so when you double click, then it will actually start as a proper Win32 UI application. So that way you can mix command line arguments, command line tool with UI tools, which I find quite nifty. To be perfectly honest, I didn't know this was possible. I mean, I sort of knew it was possible, but not like seen it much in the wild. But I recently got inspired by the Raylib tools, in case you don't know those. It's this one here. This is a nice C graphics library, basically, that runs on a shit ton of systems. And it's fairly easy to use. And he also created a lot of tools to use, like for example this one, where you can create icons, you know, and this tool can also run in as a command line version if you so choose, which I find quite cool. I think all of these can run as a command line version as well. Not quite sure. But I saw him tweet about it, and I thought that was fairly interesting. Anyways, okay. So lots to do. So what do we have? We have 1, 2, 3, 4, 5, 6, 7, 8. Do you think what I'm thinking? We could actually specify that as flags, which is nifty. So, let's call this options. Right. And yep, so let's just do that UI and flags. And we can define a few flags. Let's say input specified is options flag none. Right. I should mention what I'm trying to do here. So was that the programming view? Okay. So basically we have 8 different options that we can set, and what we can do is, instead of, having different variables for all these options, for example, like booleans, which do not really exist in C anyways because everything is an int or a byte, we can just store all 8 options into a single byte by just using the individual bits as whether this option is active or not, right? So, for example, let's say this position right here would specify whether recursive is enabled or not. If it is disabled, it would be a 0. If it is enabled, it is a 1. If we have no other command line options enabled, only recursive, it would be this. If we have no command line options, it is a 0, right? So that makes a little bit of sense. So I guess the first flag should be whether an input is specified or not. So options flag input. This is not how you do defines. Apologies. Options flag. What's the next one? Output. And that would be 2. And then options flag std out. Not 3, sorry, that would be 4. Why would it be 4? Well, because it's the next bit, which is a decimal 4, right? It's always a power of 2. So define options flag no file. So this would be 8. There you go, 8. Options flag. So we have no file. Recursive. That would be 16, and 16 in hex is, no, sorry, 10, right? Yep. 16. Define options flag. If you find hex difficult to read, you can just write 16 in here. Nothing stops you from doing that, right? But I just like using hex for these flags. So then we have headless, which would be 32, which is hex 20. Then we have append, which would be 64, so 40. And the file options flag GUI, which would be 128, which would be 80. Actually, kind of a power to these hexes as well, right? Anyways, so these are all our flags. The reason why I don't put them in an enum is because an enum is an integer, and these defines are resolved as a first compile step. So whenever you have something like this in here, the compiler actually goes through and changes this out to the actual value. And if we're then using a U8, it would automatically be a U8 as well. So that's kind of a nifty part of that. Yeah. Whoops, I removed the number there. Okay, so those are the flags we can set, and then also we want to have the input in here. Right, okay, let's set it to the same max path. We might want to revisit whether max path actually makes sense to do. Is this size appropriate? Right. Same for output. And then we have the output right here. WHRT, output, max path. Right. Okay. So now we can instantiate options. Let's just call it options. Set everything to 0, why not? Actually, you know what? I don't want to set it just now. Don't I want to set it? Let's just set flags. Flags should be options flag none by default, right? And input and output, we just wait until we have read out all the other flags. Okay. So, how do we do this? If argc is just 1, if argc is just 1, then we know we don't have any command line arguments, so we should just continue with what we were doing before, right? So in that case, we are getting the current directory. Actually, we shouldn't do it this way because that will duplicate code quite a bit. We should read out all those arguments first and then check the flags in the end and then set defaults appropriately based on those flags that we just read. So let's not do that. But we can do, if argc is bigger than 1, we want to read out command line arguments, right? So how do we do this? We do a simple for loop, size ti equals 0. I is smaller than argc. Actually, we should start at position 1, because position 0, yeah, position 0 is obviously the executable name. And let me just say I++. There you go, cool. And now we just loop through all the arguments and basically see what they are. Yeah, no, that should be absolutely fine, because if we have command line arguments that are made up out of 2 separate chunks, we can just increment I in here, right? So for example, if we have an input, right, so sorry, if we have minus input, then obviously the next thing that follows is the actual input path or file name, right? So this is actually gonna be 2 command line arguments. So if we find input, we need to increment I by 1 and read out the next one and actually make sure it's there. If it isn't there, then there is something fucked up. So, okay, read out input, which is our first flag. Let's just go through these in order, basically. If WCSCMP, right? I'm learning those shitty names. White character string compare. We are comparing argv no I, and we're comparing it with minus input. And if this is the case, we have an input, right? I don't need to really specify this, but okay. And if we have an input, we need to set our options flag accordingly. So we have options flags, and now what we're doing, we're ORing these together, right? Because we do not want to overwrite. So for example, input could appear anywhere in our command line chain, right? So we could have minus std out, minus recursive, minus input, right? And then the directory, whatever, right? So that would mean we have already set flags for these, but we obviously do not want to overwrite them, so we cannot just set them. We need to OR them together, so the bits are basically ORed together. Makes sense. So we're ORing these together with options flag input. So now whenever we have an input specified, we set the input flag. To do, we should do this before we set it though. To do read right. Let's just type them all out. Okay, we have the same for output, right? Output file name. This will be options flag output. Then we could also guard against what if this already has been set, right? Then we probably should write out some error message or something like that. I don't like to immediately put everything into separate functions. I like to write it out, as painfully as this may look, right? And then find some common patterns, which helps me then to, you know, put this in separate functions instead. That's just the way I like doing things. That gets me going a bit quicker instead of like thinking too long about how I want to structure things. Although quicker is relative because I'm a slow ass typer. So we have std out. So here we want just std out. Then we have no file. Then we have recursive. Right. Then we have headless. And we have append. And we have UI. This is append, and this is UI. Cool. Is that all? Input, input, output, output, std out, std out. No file, recursive, recursive, headless, headless, append, append, UI, UI. Perfect. So, how can we test this? Well, in debug, you can specify command line arguments for your application, right? So, if we now said input and no file and headless, for example, and start our application and make a breakpoint right here. Cool. So we can see options flags has some values in here. And how can we verify those? Well, we can go in here into the view window and say options flag but I have to put in a number now. So we want to check if input is set. Oh, it removed my... What? And the value is 1, which means it is set. So if we were to do options, flags, and let's say output, so 0x02, we get a value 0, because this option is not set, right? What else have we set? We have set, I believe, std out, right? Options, flags, and 04. No, we have not set that. Wait, what did I set? The struggles are real of my memory. Okay, no file and headless. Okay, let's do those. No file would be 08, and there we go. We get an 8 because this is set. And then options, flags, and headless. Whoa. Nope. It's 20, not 29. What did I do there? There you go. It is set. Cool. So now it's fine and dandy if we do this, right? I know people get a bit, you know, annoyed with big if-else statements. I never understood why. Like, this logic is perfectly fine, right? Doesn't mean you're a bad programmer or anything like that, even though I would call myself that. So if we exhaust all of these options, then we might have gotten something that's not recognized. right? So in that case, we want to just stop the program and give the user a warning saying like, hey, whatever you passed in here, like, doesn't make any sense. So there's an fprintf, so there should be fwprintf, right? Yes, there is. Cool. And as a file, we can say stdr, which is the standard output for arrows, which is where we actually want to be chatty, right? And then we say unrecognized argument. Yeah, let's just do that. And we just pass in whatever the argument was. Don't forget, this needs to be a long. I'm learning. And then we can return with an exit failure. Okay. Right, this is still doing what it's supposed to be doing. Okay, let's see. Properties. So if in here we would type some gobbledygook, right? There we go. Exciting. We start the debugger. Unrecognized. Huh? Oh, I defaulted it to 1, not to I. Oh my god. Okay, unrecognized argument. Gobbledygook. There we go. Cool. The joys of programming errors. Okay, so this works. This is pretty cool. Now, we probably should check whether something is set or not already, right? So what we can do is have a little function, set option flag if unset, right? So we want to set an option flag only if it is unset. And the Boolean will just return us whether it succeeded or not. What do we need to pass in? Well, we can pass in the options t as a pointer. And then we can pass in the flag that we want to set, which is just the U8 flag, right? And then in here, I mean, we could specify this as inline, so this function will be inlined, but this is, I mean, I think the function will be inlined regardless of whether we type inline or not. This is like a, you know, an historical thing where you were like giving the compiler the hint of like, hey, you should probably inline this. I don't think it's needed as much today anymore. But, you know, I'll just write it out of convenience. I don't know. It's just a habit. Out of habit. That's what I wanted to say. Okay, so now if we want to set a flag, we can say options. So if options flags, and whatever flag we try to set. So we adding these together, and then we either get a 0 if it is not set, or we get the exact flag back if it is set. So what we can say, if this is 0, then set it, right? Sorry, we need to all this together. Flag. So this is how you would set a flag, and can probably return true because we were able to set it. Otherwise, just return false. Yep. Okay. I think that's okay. So instead of ORing together like this, we now call our little function here, and if we get, you know, a false returned, then we know this option has already been set before, which means we should probably not, we should probably just ignore it. So we pass in options as a pointer, and we pass in the flag we want to set, which is options flag input. And here we can say, do we want to exit if we have specified it more than once? Probably not. More than one input specified. I'm just thinking of if I should print out the input name. I will do that later on. But for now, let's just do this. Let's just say more than one input specified. So we do the same with the output flags, right? More than one output specified. And then we can do the same with all the other ones. Whoops. Let's just copy that everywhere. As you can see, a sort of pattern emerges already, right? But we'll get to that. So more than one std out specified. Then we have no file, more than one no file specified. Should probably put these in quotation marks maybe. Should I? Yeah, why not? It just looks right. So more than one std out specified, more than one no file specified. Then we have recursive, more than one recursive. Oh my. I kind of hate this, you know? So watch. Usually if you select a word and you start typing, it will replace that word. Makes sense, right? But if you select it and then want to put like those single ticks in there, because I wanted to write a single tick, then the word recursive and another single tick. But if I press single tick now, it surrounds the word output with the single ticks. And when I type, I end up with gobbledygook. I hate it when some editors trying to be smart. Like, just let me type what I want to type. It's annoying. You have to do like an extra, like, delete stroke, and it's just annoying. Anyways, that's just me ranting. Bye. Could use Vim. Yeah, right. I'm not going down that rabbit hole. I'm sorry. I don't want to spend the next 2 weeks trying to configure Vim. Okay, so now we can test this by just, basically specifying everything more than once. So we can have input, output, output, who would have thought. We can have std out, we can have no file, sorry, std out twice, we can have no file, recursive, headless, append, and UI. Okay. Cool. There we go. More than one input specified, more than one output specified, more than one std out, no file, recursive, headless, append, and GUI specified. So I might actually terminate the application if more than one input or more than one output are specified, because that just seems obviously wrong. But if any more of these flags are specified, that just, whatever. It doesn't matter. It doesn't really change. Like, sure, it's an error in the stuff that you pass in, but it doesn't change the outcome of what's about to happen, right? If you have more than 2 inputs or more than 2 outputs specified, like, which one is the one you're actually wanting to use, right? So we do not want to do something wrong there. So this is probably more of an indication to the user, hey, you seriously need to check this, while the other ones are more like, yeah, you did something dumb, but it doesn't matter. So what we're probably going to do is return exit failure on input and on output. And then we can say input already specified. I already wrote the word specified. Which one did you want to use? Yeah, we can say the same for output. And we can actually say error. It's a bit nicer because those are terminating errors, right? While the other ones are more or less just warnings. Okay, but now, as I said, input and output are a group of 2 arguments. So really what we need to do is let's say size t next equals I plus 1, right? I don't like prefix and postfix that much, except for like pointers or like little things like this. So let's just do I plus 1. So next, if next is exactly the same as argc, then there is no extra argument anymore, right? So the path that we're expecting is missing. So this is a definite error. Error. No input path specified. Input path missing. How about that? That sounds better. And then we have return exit failure. Okay. However, if next is actually, we don't really need next, right? I could just do, let's just increment I, because we need to increment it in the end anyways if it actually exists, and this is the terminating error anyways, so yeah, let's do that. So we increment I, go to the next argument. If that one doesn't exist, we throw out an error, and let's do the same for output as well. Output file name or path. Output path or file name missing. Okay, so if we now go in here and say just input, we should terminate. Error, input path missing. Cool. And the same thing should happen if we have output but nothing else. Error, output path or file name missing. There we go. Now, we kind of need to, this is a bit tricky, because what if we do output and input right after each other, right? Then obviously it will just work. But our input path is now a wrong value. I don't know if I should actually check whether a string is starting with a minus just to determine whether this might be another command line argument and then it's actually missing or not. You know what? We can do that. So if I is equal to argc, or if argv I, and this is funky now, 0 equals minus, and we probably should do an L. Right? No? Oh, I did it with output and then followed by input, didn't I? So let's put this here as well. There you go. Error, output path or file name missing. Because the next thing is actually another command line argument. But if it doesn't start with a minus, then we can just, assume it is the correct path. And if it actually isn't, then it will fail further down the line when we actually try to create a file or read files out of that particular path that has been given by the user. So in any case, what we now can do is WCS CP Y, right? Yes, that is a string copy. Fantastic. And what we can do is options, input, actually, I just realized we probably should do this after we check whether the flag has been set or not. Right. So, there's so many spaces. Okay. Try and set the flag. Try and fetch next argument. Try and copy argument. So, white character string copy s. The destination will be options, input, size in words will be, I believe, yeah, max path. We should the number copy instead. The source will be argvi, because we incremented I, so that is fine. And then the max count, I think you can use truncate here, but let me verify. The number of characters to be copied or truncate, right? Do we want to truncate though? No, we do not want to. So we should just set this to max path, right? I was just curious what happens if your argument is actually shorter than what you're specifying here as the count. What would happen? So let's just try this out with like some random string. Let's say we have whrt buffer, or let's call it string test. Let's say 5 characters. str test, we specify 5 here, and we specify 5 here. And then what we're passing in is actually just 2 characters. Right. Okay. Result is 0, and it's just AB. Okay, fantastic. A, B, C, D, E. That would be 5 characters, right? Without the null terminator, will they fit in? Ah. Buffer is too small. What if I do this in release? Interesting. I basically want to prevent this hard crash. So strn len is only intended to be used to calculate the size of incoming untrusted data, which, you know, command line arguments are. Because, like, It could be God knows what. So let's say, okay, let's say we have a wchrt of test 1, 2 characters, A, B, right? So test 1, and the max count is 5, because that's what fits in our buffer, right? Size t, size 1 equals this. Then we have size t, size 2, vcs, and len s. That will be test 2, also a max count of 5, wchrt, and let's say test 2 will be a, b, c, d, e, f, right? So it's longer. Then we should probably have a test 3 with exactly 5 characters, and then we should probably have a test 4 with 4 characters. Cool. Let's sort them by size, why not? I just want to see what the different results are of all of these things. So 3, 4. I should probably 2, 3, 4. Let's do it correctly. 3, 4, and 1, 2, 3, 4. Right. So what are we getting? Okay, size 1, as expected, is 2, which is pretty great. This is size 4, which is great. Size 5, superb. And this will just return size 5 as well. Interesting. So, hang on. This will be test 1, size 1. Okay. This is how I like to test things when I'm like unsure with certain things, you know, just write some random code in your application, step through with the debuggers, see what happens. Okay, so we're trying to fill the buffer with 2 characters. Bam. Result is 0, which is fine, and our test now has those 2 characters. Now we're trying to do the same with 4 characters. Bam. Again, works fine. Now we are on the test case with 5 characters. Wait, are we? Yeah. Okay, which should be 5, but only 5 fit in. Okay. Buffer is too small. Okay, that's in debug assertion though. So actually what this should be is 4, right? Because we ignore the null termination when we do the length, but in here the length needs to be included. Okay. Interesting. Okay, let's do that again. So this will just work. Yep, this will just work. Okay. Result 3 is 0. And this will now work. Wait. No, this won't work. Why is result 0 then? Oh, does it just copy however much you specify? Okay. It does. So effectively truncating it. I mean, I can truncate it, why not? That's fine. Yeah, whatever. Let's just truncate it. Okay. So what we then want is, let's call it path length, and we do the same thing as we did there with WCS and LenS. What's those names? We want to know the length of the arguments that we're trying to copy in, and the max length we set to max path, right? Because that is our buffer. Except we want to set it to max path minus 1, right? And then we're doing the copy to input, and what we're doing is using path length. Now, if this copy fails, then something went horribly wrong, and then we can use our print CRT error method. Fail to copy input path string, and then, yeah, whatever the error will be. Should I print that one out? Nah. That's okay. Why are you doing that? Did I forget a brace somewhere? There we go. Okay. And this will also be in terminating failure. Okay. So now, let's see if it works. Let's say we have input, yada yada, or whatever. Fire in the hole. Oh, still have this shit in there. Wait, what? Why did you not hit? I mean, if I would spell input right, that would also help. I struggle sometimes, ladies and gentlemen. Okay, options. Options, input, right here, yada yada. Cool. And now we can just copy this thing and use it for the output path as well, right? So let's do this. We can remove the to do. So output path or file name missing. We have path lengths, that's still the same. We need to change this to output. And there we go. We should be able to set our output as well now. So output, yo, yo, yo. And let's see, options, output, there we go, yo, yo, yo. Sweet. Okay, so this is basic command line reading. Now we can probably extract this and make this a little bit nicer as well. So really what we're having is optional flags, right? Will be just one. And then we have two, I don't want to call them mandatory flags, but like, what do we call this? Set check option with warning, I suppose. Okay, yeah, whatever. What we can pass in is a const white character and the, let's call it name, the option name, right? Okay, let me explain. I might have jumped ahead. Basically what I want to do, I want to take this and put this in here, right? So we do not have to repeat all this code. So we have the name, which will be this little thing. And then we have the argument, which will be this one. Set option with warning. How about that? And then we have our options struct as a pointer where we want to add the result. Okay, so if this one if argument is the same as the name, right, but we need the flag in there as well. Yeah, whatever. Flag. So we have the flag, we have the name, we have the argument, and we have the options. But actually we want to put in the options first, I suppose. Set option flag, and then the other arguments. Yeah, that makes logical sense, and it's also the same as up here. Okay, cool. So here we can terminate early. So basically what we can say, if WCS compare argument, actually, is there a safe version for this as well? No. I suppose it doesn't matter because one side is trusted and the otherwise isn't, right? And given that the trusted is the first one we're dealing with comparing against, then it doesn't matter with what we're actually getting from the user. So, okay, this should be safe regardless. So if argument is the same as name. Now, if they are not the same, just return early. Then we can call our set option flag if unset, right? We can probably mark this as inline as well. I mean, we probably don't need to, but whatever. Set option flag if unset, and this one needs to be the flag that we want to set. And then here, warning more than one, %s specified, and what we're just passing in is the name. So it will print out minus std and, or minus input instead of just input, but whatever. So if these are not the same, then we return false because this is not that flag. If we're trying to set it, I think we just return true anyways, because it is a known argument to us. That's a bit shit, isn't it? Let's just call it check and set option. Okay. What did I have down here? Shoot. std out, right? So we need options. We have the flag options flag std out. We have the name, which is minus std out. And then we have the argument, which will be RVI. Right? I might have made a bit of a monstrosity here. Because what this would boil down to is and then just all them together. Whatever. That's fine. Okay, we have minus no file, flag no file. We have minus recursive with flag recursive. We have minus headless. Append minus append, and we have one more, which will be GUI. This is a bit ugly. Okay. Now these two are a bit special, aren't they? I kind of want to leave these two as is. Yeah, why not? Okay, I definitely want to put this in its own header file, so let's do that real quick. So new item, header file, options.h. I don't like this Pragma 1 stuff, so that's why I'm doing it this way. Okay, and we want to include it, and then this struct and these little things should go over here. Okay, yeah, and then we can have something like read command line options, option T, options, right, and then just take all of this, put that in here. Oh, I forgot the option flags, my bad. Okay, and instead of that we're doing argc, right, which will return, which we'll call this, which is an int pointer. So let's do that. Yeah, wrong language. Sometimes my Swift comes out. Or Rust, I suppose. Whatever. What do I want to do? Oh dear Lord. Okay, so int argc, whatever this is pointing to. No, it already dereferences it. Okay, so args equals this. Right. And then we have no, it's wrv, which calls this, which is a pointer. And we're dereferencing it, which means we're left with a pointer. Which is exactly what we want. can simplify the name a bit, obviously, if we just write it out like this instead of pointer pointer. Because what is a pointer pointer? Well, it is an array that contains char pointers. So pointer pointer really is an array full of some type that is a pointer to that type, right? And then pointer 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 is a pointer to an array that contains the type full of pointers. That's one way to think about it. I love C. Okay, now I specify the variables here. We're fetching them from the globals right here, right? So we can use them in here. That is cool. So now every time we call options, we actually have to do this little thing, right? I almost dislike this thing. I kind of liked it when it was all just one, you know. Do I want to go back? It's one of those instances where trying to abstract it too much and factor it out might not have been a good idea. Honestly, let's look at it. What's wrong with this? Right? It does the exact same thing. It's just a bit clearer than this. So let's just right, whatever. So we don't need this one. I should have recognized this as soon as I started to like struggle with the names and, you know, struggle with reasoning about the names. So what do we need to include here? We need to include std bool, right, for boolean. We need to include std lib. Do we? stdio. stdio. And I assume string. stdlib, okay. And then select jar. Actually, we could just include type def h, whatever. And then max path really So if max path is not specified, we just specify it ourselves. Okay, options. I mean, you just have a vague understanding of how pointers work physically on the memory. I mean, I could try and explain it real quick. So let's say this is our memory, right? And let's pretend this is an 8-bit machine, right? 8 bits. So each of these entries in memory would be 8-bit wide, or it could be any size, you know, on 64-bit machines. This would be 64-bit, right? And then, so let's just assume the memory goes from top to bottom. Then you can address each single bit with an index, similar to an array, right? So this would be index 0, index 1, 2, 3, 4, 5, 6, 7, 8, 9, right? Let's say we have a variable called foo with the value of, I don't know, 15, right? So let's say whatever, int foo equals 15. Now the compiler or the runtime or whatever might choose to put this in memory at location 3, right? So whenever you're calling foo, really what you're saying is the value in this memory location should be used for whatever, you know, like, so for example, if you say foo plus 1, foo equals foo plus 1, then all this means is like, okay, look in this location of memory, increase this by 1, and then it's value 16, right? So you can give these specific names, basically, is what I'm saying. So if we had a second variable, for example, we had bar right here with the value of 42, then this location in memory would be named bar. It's not exactly like that, but that's like the mental model that you can have. Now a pointer, if you have an int pointer, let's call this PTR, right? And let's assume it lives in this location, location 7, right? And you want to point to a variable somewhere in memory, then you can do this by taking the address of that variable, for example, of foo. Now, what does that mean? So getting the address of a variable with the address operator foo just means get me the address of where this variable lives in memory. So in our case, as you can see here, the address, well, I wanted to do this in red, but somehow the address would be 3, right? So basically all you're saying is pointer points to something that is on location 3, which is 16. Pointers itself are nothing special. Basically, this is just treated as another variable. And what it would do is store the address it needs to point to in here as a value. Right? So then every time you look at PTR, I mean, you need to dereference it, but dereferencing just means give me the value of the thing you're pointing at. So in this case, you have PTR, which is value number 3, and you want to have the value of what it's pointing at, so it goes to 3. It sees, okay, I have to go to memory location 3, what is stored in there? 16. Therefore, I'm showing you this would be 16. Not sure if I can explain that correctly, but this is how you can roughly think about it. And then you can add as many indirections as you want, right? For example, a pointer to a pointer, right? So again, you can have, let's do this in blue, you can have pointer 2, which points to location 7, right? So you have int pointer 2, which points to the address of pointer 1. So all that means is this particular hang on, it needs to be pointer of pointer, sorry. So this particular pointer points to address number 7, which is up here, which we see is another pointer that points to address number 3, which is the value 16. I know it's a bit hard to wrap your head around this, but basically all you have to think about, if you have a pointer, all that means is it is an integer value that holds the address to something in memory, to you know, a block of memory basically. Okay, let's switch back. I mean, I also still stumble with like pointers of pointers and all this kind of thing. So let's say, for example, wchrt pointer, right? Whoops. What does that mean, right? And so we're saying a pointer points to a location in memory, right? So A actually doesn't store this value that you're seeing right here, which is called test. This string is stored somewhere else in memory. The compiler decides that during compilation, it sees like this string here and just puts this test string somewhere in memory. And what you would then see is like, let's say this is address, let's say it is on address 5, right? So on address 5 you would have the T, address 6 you would have E, on address 7 you would have S, on address 8 you would have another T, and then on address 9 you would have the null termination character, which just indicates the string is over. So null termination is just the number null, really. This is just a convention to do this as characters like this. Anyway, so all this means, if you have a wchrt pointer, all that means is that A now has the value 5, right? It points to the location number 5. What is location number 5? It is the T. So how would you get the E? Well, you increment the pointer by 1, right? So now it would point to location number 6. What is on number 6? There is the E. And then so on and so on. Every time you have a pointer, one way to access these values is similar to an array, where you can just say, okay, give me your first location. What is the first location? It's location 5, which points to a T. What is your second location? Right. It is location number 6, so it points to the E. So yeah, that's essentially how strings works with pointers. It's kind of easy once you get it, but you definitely still get tripped up. I assume if you have like 10 years of experience on this in C, you probably like don't get tripped up anymore as much, but I still do. Especially like when it comes to pointers of pointers and stuff like that. It's still hard to think about these abstractions, but anyways. Okay, so we have read command line options in a separate function. So what we now want to do is we want to say false if it fails critically, right? And otherwise, we're just going to say true. Or we can say if argc is smaller than 1, we just return true. And actually what we can do here is also flags 0 out the flag with options flag none. So no longer need this if. And then here we just return true. So now every time we have a failure that's like where we should exit the program, we just return false all of this method here, function, and then otherwise we just return true. If we do not have any command line arguments or just, the basic default one, which is the executable name, we just return true as well, because that just means we do not have any options flags. For that, we actually reset the options flag, so, they're properly set before we call them, so we don't have to do this on the call side. And now, I believe if we just get rid of all of this again. Type in import project headers, and we include options H. And then here we do not need to instantiate it, we just have options. Then we call read command line options with an address of options. And if it fails, we simply call exit failure. We do not need the braces. So, okay. Build failures, what did we fuck up? Oh, what? Signed, unsigned mismatch. Sure, make this a size T, whatever. Nope. Ah. So this function expects a pointer to the options, and what we're doing here is we're getting the address of where options live, but it is already a pointer, so essentially what we're returning here is a pointer to a pointer, which we do not want, so we need to remove the and now. The address of operator, essentially. Because we already have a pointer to options, we just need to pass the pointer around. There's no need to get the address of that pointer anymore. Okay, print CRT error we do not have, which is correct. But we also do not need it. What we can do is underscore void p error, and the error message is exactly this. The same here. Well, there we go. Nope, still not. What? Oh, are you kidding me? Can't I just do that? Really? Okay, whatever. Pedantic. Okay, so options flags still get set. We have an input and an output path, so that all works just fine. So now that we read the command line options, we can do our actions against them, right? So let's start by picking out the flags, right? So if options flags is options flag none, then we do not have any command line options whatsoever. Now, what should we do in that case? Well, exactly the same thing that we did before, which means getting the current directory. But we also need to get the current directory if input is not specified at all. So if this is the case, or if options flags, actually we can probably make a nice function for this one as well, to be honest. Inline bool check option set, check option is set, options t options u8 flag, and we can just say return if options flags and flag equals flag. Oh, okay, equals has higher precedence than the AND operator. That makes sense. This reads nicer anyways. I don't know if I like casting, like, you know, the result of this directly translating to a bool. Because one is true. But like, yeah, I'll just do it like that. So anyways, we could write this out all the time, but then you would have to type the flags twice, and I don't like doing that, so I think this is perfectly fine. And it's also inlined, so that should help us. Alternatively, we could make this a macro. Should we do that? Should we do a macro? Yeah, let's do the macro. Come on. Option is set, and we have option and flag, and this expands to option.flags. There we go. Put braces around it. Okay, so if options flags is options none, or option is set, which will be options let's call it options flag is set. And the flag we want to check is options flag input. Hang on. I'm being dumb. We want to check if it is not set, right? Oh dear. Is unset. So if this is the case, then the input path should be the current working directory. And instead of the input path buffer that we had before, we can now use options input right here. Okay. Now, let's try it out. So, let's try it out without anything. So we have no command line options whatsoever, and what we're expecting is to land in here. Now we're getting a build failure. While we're getting build failure, because we still have input buffer used down here, which should now be options input. Okay, let's go. Cool, and indeed we're going here. So if we have no command line options, we're just getting the current working directory. Fantastic. Okay, now we do the same with well, we just need to set anything, right? So let's set std out for now. So we have something in there. And we're getting in here. And why are we getting in here? Because options flag is unset. And we can figure that out by doing exactly this. Options.flags, and our flag that we want to check is input, which is 01. So options flag and whoop. Oh, options flags. As we can see, it is 0. Okay. What if this is a file name? Well, that will be something to check later on. I think it will be failing later down the line when we try to do the find file stuff and do it over a file name, right? But I'm not too concerned about this for now. But input, let's just assume it works. Actually, instead of assuming it works, what we can do is, let's rebuild this. Go to here, fetch that out into here. Actually, no, it doesn't need to be in there, does it? I don't need to fetch it out at all. We say copy as path, go in here. Whoop, thank you, I guess. Okay. CD. Let's go in that folder. And then we run GB Header Extractor executable. So if we do that, it still tries to use the current directory as the input path, right? Yep, that's what we're doing here, all right. But now if I were to specify input, and let's say we're taking this folder instead. Ha! Current directory, and it's the directory that we just specified here. Actually, now I can actually test what happens if this is a file name. So output CSV, right? So couldn't find first file in directory. The directory name is invalid. Perfect. Okay, so we can remove this to do. This is perfectly fine. Fantastic. Okay. So that was how we deal with the input path. Now with the output path, we kind of do the same thing. So if options set input path defaults, set output path defaults. So if options flags options flag none, or options flag is unset, options flag output. So we have no command line arguments, sorry, no options, or we just didn't specify an output option. Then what we want to do is we just want to set the output path to the same as the input path and just attach output.cvs onto it. This will be options output. So we first copy the input path into the output path, and then add path separators and output.csv onto it. And if this doesn't work, we exit with a failure. That is fine. Now, otherwise, so we have options and the output option flag is set. What we probably want to do here is to do check if output is actually a file. Because if it isn't, then we just oh, thank you for the follow. If the output is just a directory, we're just gonna attach the default output name onto it, because I don't know, maybe a user doesn't want to specify, you know, a file name or whatever, so we can just provide one. Why not? How do we check whether this is a file or not? Well, the easiest thing to do would be, I could check for a file extension, but not every file has a file extension, right? So what we need is like to get the file attributes out of it. Let's see if, I mean, surely Windows has something like that. Oh dear, that's a lot of tabs. Okay, let's say Win32 get file attribute. Get file attributes, there we go. We want the W version. We just have a file name. If the function succeeds, the return value contains the attributes of the specified file directory. For a list of attribute values, file attribute constants. Is that even the right thing that I want? That's the question, right? So what are the file attribute constants? File is read only. Okay, we can see whether it is a directory or not with file attribute directory, which is, I think, what I'm exactly doing down here, right? When we iterate through all the files. Scroll, scroll, scroll. There we go. Double word file attributes. And I'm checking for file attribute directory to distinguish between files and directory. So we can just do that. That's excellent. Why are you complaining? Oh, output path is no longer a thing, right? Because we have this in options.output. Okay, let me fix that real quick. Okay, cool. So now we can check the file attributes. Get file attributes W, which means we can just check this, because if you leave out the W or A, it's just a macro that will either reference the white character version or the ASCII version. And we have a file name, and the file name will be options.output. Right? So we get the attributes, and then we can check whether the attributes are actually what we can do is else if get file attributes for options.output and check whether this is a directory. And if it is a directory, okay, actually we can simplify this a lot, right? Because we can just plug it into this if statement here. So we either have no flags, we have no options flag, or we have an options flag, but it might be a directory. No, that doesn't work. That doesn't work. I apologize. That doesn't work. No, 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 no. We need to do this separately because it has slightly different parameters here on the combined path. So on the combined path, we still want to store this in output, but we do I need a buffer for that? Let's think about this. Where's my combined path function? What's going on? Why are you complaining? Oh, because I don't have a starting brace. That's why. Okay, got this? Okay, so now I can... What? Why is it not jumping to combined path? Whatever. Almost feel like I need an append path. So let's do that. Sorry, let's copy this one. Call it append path. An additional. So we do not need to copy the first component, add path separator if it doesn't exist, which means we have path, last character. We concatenate to path this thing. Fail to append path separator to path. If additional is null, we return null. Actually, return false. Let's fix that up here as well. False. Additional. And we have second length, which we can just call length. And then we just have path and additional. We do not need this. Oh. Apparently we do need that. Let's call this path length. Okay, now we have an append path. And instead of combined path, we say append path because we want to append output CSV onto the output directory that we've got right here, right? Cool. Okay, let's try it out. Where should we put this? So this still works, right? GB Header Extractor, yeah, we have an output CSV right here, because this is the working directory of the application. But let's assume we want to put it in here, right? Let's do that. Output equals this one. Yeah, that works. Cool. So the output path works. So if we just pass in a path, it will just, name it still output CSV, but we could also give it a file name now. Let's say test CSV. What? Why? So I passed in the file name and it still attached output CSV onto it. That doesn't seem correct, does it? Okay, so options output, we have test CSV, okay. Why do you think this is a directory? Oh, is it because of all the double slashes? Right. What? Why? Because the file doesn't exist, obviously. Duh! What attributes am I trying to get? Right? Oh no! I mean, it's kind of hard to figure out, isn't it? I could assume it is a directory if I put the... Okay, this is a bit trickier than I thought it would be. So, can I check for directories? I mean, there's directory management, right? That's definitely something I need to leave for later. I'm not gonna be able to do that now. There's a bunch of things we can do. But that is very involved. So first, check if output ends in path separator, right? If it ends with a path separator, then we can for sure say it is a path. Let me just append file name onto it. Now, if it doesn't end in a path separator, then we should check if it ends with a file extension. So if there is a dot somewhere in between. But it needs to be at the last segment. So first we need to figure out the last segment. This is like sub-steps involved in this, right? So 2.1. find last path segment. Find dot in last path segment. And if it has a dot, then it is for sure a file. Don't append anything. But then it could be a file name without an extension. And this is where the tricky part comes in, right? So it could either be a directory or it could be a file. So, and we could do 2 checks here. Well, this might solve all my problems. Where is that in? SHLW API. What on earth is that? Shell lightweight utility functions. I do not want to import another lib. No. No, thank you. Okay, stupid idea. How about I could do these checks. And after that, we just try and create /open file. If it fails, append default file name. Basically just try and open it. Try and open or create it. Done. And if it fails, we should for sure know this is a directory. Something isn't right here. And then we just append and done. And if we're able to create it, I mean, that's good, right? Then we can just leave it open and already use it. Yeah, okay. But this is for next time. I'll definitely have to stop now. Probably won't be able to stream much more today. So this will be tomorrow's problem. Maybe I'm just overthinking this, and I could just say, okay, if you have an output specified, it's your responsibility to have a right thing. Otherwise, we just fail further down the line, which is also perfectly valid. This is just a nice to have, really. Actually, yeah, let's see. This is just a nice to have. I'm more concerned about sorting these out, except Win32 UI mode, obviously. Okay. Well, that's about it. Why is this squiggly now? Read ROM headers not found. Is this a bug again? No. Cool. Yeah, whatever. It compiles, that's all that matters, right? Does it compile? I hope it compiles. Yeah, it does compile. Okay, cool. Well, I think that's it. So, I'll see you next time. Bye.